Hello friends, welcome to my channel. So in this video we are going to discuss about the properties of aggregates. In the previous video we have discussed around 8 properties. Now we will continue with the 9th property, that is bulking of aggregate. So we will move forward with the 9th property, that is bulking of aggregate. So first of all we will see what is meant by bulking of aggregates. So bulking of aggregates is simply increasing in the volume of particular aggregates, okay, and this bulking is occurs in aggregates due to free moisture content, okay. So this bulking of aggregate is causes due to free moisture content, okay, and due to this free moisture it forms a thin film around the aggregate particles, okay. So it forms a thin film around particles, okay, and then whatever this film which is formed due to free moisture is then exerts the surface tension, okay. It exerts surface tension, okay, and surface tension, due to surface tension these aggregates, these particle of these aggregates are keep away from each other, okay. So surface tension keeps that particles away from each other, okay. So we will discuss diagrammatically. Suppose these are some particles of aggregates, okay, and as we mentioned firstly that it is the bulking of aggregate, it is caused due to the free moisture, okay. So whatever this free moisture, when aggregates are exposed to the free moisture, then it forms a thin film around particles, okay. So thin film formation is occurs around these particles. So these are the thin films which is formed due to free moisture content, okay. Then this thin film is exerts the surface tension, and as we know that surface tension is simply keeping away from each other. It is the property which keeps each particle away from each other, okay. So due to surface tension these particles are get away from each other, and as we can see that there are some voids are present, okay, between these all the particles, and that simply causes the increase in the volume, okay. So this gap or this void, it causes increase in the volume, and that directly imparts the bulking, okay. So this is about the bulking of aggregates. So the methods of determining the bulking of aggregates, that is first one is by drying method, then the second one is displacement method, the third method that we use, it is calcium carbide method, and the last method that we use to determine the bulking of aggregates, that is measurement by electrical method, okay. So the last one that we use, that is measurement by electrical method. So this is about the bulking of aggregates. Now we will move towards our next property. Then our next property, that is cleanliness. So this cleanliness is simply deals with the impurities in the aggregates, okay. So cleanliness, it deals with impurities in aggregates, okay, and these impurities can be cause very much effect on the concrete matrix, that it may reduce the workability, okay, it may reduce the strength factor, it affects the strength also, okay, and other various parameters which the cleanliness or impurities impart on the particular concrete mix. Now we will see what are the impurities. We will take two examples of the impurities and we will see what they imparts on the particular concrete mix. So the first basic impurity which is present in the aggregate, that is silt and clay. Okay, silt and clay. Now as we know that silt and clay, since they absorb water, okay, since they absorbs the water, that's why if the impurities like silt and clay present in our aggregates, it increases the water cement ratio. Okay, so it simply increases the water cement ratio. Okay, then second impurity, which is finer than the silt and clay, which is in the mineral form, that is mica. Okay, so if this mica present in the aggregates, then it will reduces the compressive strength. Okay, so it simply reduces the compressive strength. Okay, so this is the one of the basic property that we study or that we evaluate while we are dealing with the aggregates. So this is about the cleanliness. Now we will move towards our next property. Then our next important property, that is soundness, which we study while dealing with the properties of aggregates. So soundness, it is simply the resistance to the excessive change in the volume. Okay, so soundness, it is the resistance against excessive change in volume. Okay, excessive change in volume. Okay, and this soundness, it can be determined or it can be seen or observed by the physical condition. So it can be observed by physical conditions, by studying the physical conditions, and these physical conditions are freezing. The second one is thawing, and the next one, that is variation in temperature. And the last one, that is wetting and drying. Now we will see these physical conditions. So in the freezing state, whatever the water molecules or water, okay, this simply goes into the pores of these aggregates. Okay, so it goes into the pores of aggregates, and in the pores it get freeze. Okay, or it simply get converted into the form of ice. Okay, so it's simply converted in the ice form, and when it forms the ice, that changes the volume. Okay, so this ice causes in the change in volume. Okay, so this is about the freezing condition. The thawing is exactly opposite of the freezing. In the thawing, the same thing happens, that is water goes into the pores, and in the pores there is already presence of the ice, but in the thawing case, this ice is get melt. Okay, it get melt, and this also causes the change in volume. Okay, this causes the change in volume. Okay, the same thing happens with the variation in temperature, that is increase or decrease in the temperature, it affects the soundness. Then wetting and drying also deals almost the same. Okay, so this is the basic thing about the soundness. Now we will see how this soundness is determined or measured. Now we will see how the measurement of soundness of aggregates is done. So first of all, we take the solution of sodium sulfate. Okay, sodium sulfate, or we can use the other alternate solution, that is magnesium sulfate. Okay, magnesium sulfate. Okay, then we oven dry these both of the solution which contains the aggregates. So oven drying is the next procedure. Okay, and if we using the sodium sulfate, then whatever the change in the area, it should be less than 12% in case of sodium sulfate, if we use the solution as a sodium sulfate along with aggregates, and if we use the magnesium sulfate solution along with aggregates, then the change in the volume should be less than 1.8%. Okay, So on the basis of this percentage, we measure the soundness and we derive that whether the aggregates are sound or unsound. Then our next property that we study while dealing with the aggregates, that is durability. So durability, in the simple terms, it is simply the serviceable lifespan of any structure or any material. So in the case of aggregates, while we're dealing with the durability of aggregates, then we consider some factors like, as we know that aggregate has content of silica. Many of the aggregates have silica as a content, and when it reacts with the alkalis, okay, when it reacts with the alkalis which are present in the cement, then it reduces the durability. Okay, it reduces the durability. Okay, now we will see the reasons why they reduces the durability of the particular concrete. So the factors which affects this silica alkali action, these are mainly the reactiveness of the aggregates. Okay, reactiveness of particular aggregates. Then the second factor which affects the durability, that is the presence of alkalis in the cement, or simply we say the content of alkalis in cement. Content of alkalis in cement. And then third one, that is moisture conditions. And the last one, that is temperature conditions. Okay, so these four factors which affects the durability property while we dealing with the aggregates. Now we will see that as we know that these causes the low durability. Now we will see how to increase the durability. So we will deal with these four factors. So in case of we have to increase the durability, then reactiveness of the aggregate should be in the less quantity. Okay, so whatever the reactive aggregates in our concrete mix, that should be in the less quantity. Then the content of alkalis in cement should be low as much as possible. Then the moisture condition should satisfy all the required terms. Then temperature conditions are also maintained in the controlled environment. So by this way we can achieve the durability, and along with that, addition of pozzolana. Okay, addition of pozzolana, it increases the durability. Okay, increases the durability. Okay, so these measures can be taken out to increase the durability. So this is all about the durability property. Then our next property, that is thermal properties. So in the thermal properties, we deal with the temperature conditions. So in these thermal properties, we deal with the temperature conditions. And as we know that as aggregates used in the concrete, so concrete can be divided into the two types if we study that on the basis of thermal conditions. First one is hot weather concreting. Okay, first one is hot weather concreting, and the second one is cold weather concreting. Okay, is cold weather concreting. Now hot weather concreting, that means whenever we work above 40 degrees Celsius, then it is termed as the hot weather concreting, and whenever we works under 40 degrees Celsius, then we called it as a cold weather concreting. Now if we working in the hot weather concreting, then the admixtures along with the aggregates in this and cement, along with aggregate and cement, the admixture that should use that in the hot weather concreting to reduce the heat or heat of hydration, that is pozzolana. Okay, that is pozzolana, or simply we can reduce the content of tricalcium aluminate, tricalcium silicate. Okay, that we have already seen in the cement part. Okay, so in the hot weather concreting, these thermal properties can be maintained by using these pozzolana and by keeping these box compound in such a way. So next condition, that is cold weather concreting. Now in the cold weather concreting, there is a less heat of hydration, so to increase the heat of hydration, we simply add calcium chloride, or simply increase the admixture proportion of the calcium chloride. Okay. And also we do the same thing as we done. Also we do the opposite thing that we have done in the hot weather concrete, that is increase the content of tricalcium aluminate and increase the content of tricalcium silicate. Okay, so these are the basic things that we kept in mind while we are dealing with the thermal properties. So this is all about the properties of aggregates. In the next video we will discuss about the grading of aggregates. So thank you so much for watching this video. Please like, share and subscribe.